Some examples of ways that we can solve of systems of equations are graphing, substitution, and elimination. Today, we are going to focus on the elimination method. The elimination method relies on you eliminating or taking out one variable to be able to solve. You can do that by adding the two equations when the coefficients are opposites of each other. You can take out the x variable or the y variable depending on the coefficients of the two equations. Let's go through an example. In this example, the y variable has two coefficients who are opposite of each other. Since the two coefficients of the y are opposites of each other, that means we can add. So we can add positive 4 and negative 4y. So let's add. Since we add, 4x plus 6x is equal to 10x. 4y plus negative 4y cancels each other out, and negative 4 plus 24 is equal to 20. Now we must divide each side by 10, and we get x is equal to 2. Next, to find the y-coordinate, we must plug it into the original equation. So as we plug it in, 6 times 2 minus 4y is equal to 24. And let's solve. 6 times 2 is 12, minus 4y is equal to 24. We're going to subtract 12 from both sides, and we get negative 4y is equal to 12. As we divide by negative 4, we get y is equal to negative 3. In order to find the solution of these systems of equations, we have to put it into a coordinate pair. Coordinate pairs are formed x, comma, y. So we do 2, comma, negative 3. And that is our final answer. Now, let's look at the second example. Since the elimination method relies on eliminating or taking out one variable to be able to solve, you can do that by subtracting the two equations where the coefficients are the same. We can see that the x variable has two coefficients that are the same for each equation. Therefore, we can subtract. So let's subtract this one. We have negative 2x minus 2x, which gives us 0. We have 2y minus y, which gives us y. And we have 2 minus negative 4, and that gives us positive 6. Now we must plug in our answer for y to find x. So we plug in negative 2x plus 6 is equal to negative 4. We subtract 6 from both sides. We get negative 2x is equal to negative 10. Divide by negative 2. And we get x is equal to 5. Now we must solve these systems of equations by doing the same thing we did last problem. We plug in. We have x comma y as our coordinate pair, and we plug in 5 comma 6. Please make sure that your x corresponds with the x coordinate and your y corresponds with your y coordinate. As we know, example 2 dealt with a lot of negatives, and sometimes negatives can be tricky. What if we don't want to subtract or deal with all these negative numbers? An alternative method is to multiply by negative 1. Let's multiply the bottom equation by negative 1. So we get negative 2x plus 2y is equal to 2. 2x minus y is equal to positive 4. When you multiply by negative numbers, especially negative 1, it's good to remember to flip the sign. So multiplying by negative 1, you just flip every sign on the bottom equation. So now let's add. Negative 2x plus 2x, that gives us 0. 2y plus negative y, that gives us y. And 2 plus 4, that gives us 6. Now let's plug what we got here into this equation. So we get negative 2x plus 6 is equal to negative 4. We subtract 6 from both sides, and we get negative 2x is equal to negative 10. Then we must divide by negative 2, and we get x is equal to 5. This answer must follow the same coordinate formula as before. So x comma y. So the answer is 5 comma 6. And your answer should be the exact same answer as example 2. Thanks. I hope you enjoyed this video and keep watching my others.